Hello, ladies and gentlemen, and welcome to the second semester of geometry. And we are going to start with Chapter 8, Section 1. And all of Chapter 8, we're only doing the first three sections, I believe. And all of Chapter 8 is dealing with Pythagorean theorem and its converse and right triangle work. So all of the things that we're doing are right triangles. And please don't think that they're anything but right triangles. We're going to try and prove that triangles are either right triangles or they're not right triangles. And we're going to find different ways of finding the sides of right triangles and different ways of finding the measures of right triangles as well. So you will have a scientific calculator, or you will need one, or it is going to be really difficult for you, or close to impossible, to do any of the work. So hopefully you go out and you buy your TI-30XS. That's this calculator. All right, parents, there it is. It's usually anywhere around $20. I wouldn't pay more than $20. Usually Amazon, you can get it for cheaper, buying it online. But however you wish to get it, this is the one calculator you're allowed to use for the exam, so you need to practice using it or have it so that just like any other tool, you're able to be successful as we move on. And I will at times be referencing this calculator so that you understand why I need you to use this tool. I'm going to reset mine so that we're ready to go. All right, so we start with the Pythagorean theorem. All right, and when dealing with the Pythagorean theorem, it's a way of finding the sides of a right triangle if you know two of the sides. So, for example, we have two sides with a measurement on it, and we need to find the third. Then we can use Pythagoras' theorem, or Pythagorean theorem. Right? And most of you remember what Pythagorean theorem is. It's a squared plus b squared equals c squared. Okay? Now, will you have to remember that? No, because you will have it on your reference sheet. Most of you remember your reference sheet. Sorry for the glare. Okay, Pythagorean theorem is on there, as well as the trigonomic ratios and all the things that deal with right triangles. Okay, a squared plus b squared equals c squared. All right. Now, of these three sides, which one is the most important? It's the only one that has a very specific name. Can anyone tell me what that name is? Correct. Hopefully you said the hypotenuse. Okay, this side is the most important side. Why? Because it is across from the right triangle. Its name is always the hypotenuse. If you can identify the hypotenuse and you know the name of it is called the hypotenuse and you never call it anything but the hypotenuse, you will be good. Okay? The hypotenuse is your C side. It's not C squared. You have to square it, but it is the C side. It does not matter which one of these you call A or B. It will make no difference in the problem. Well, some of you are like, well, wait a minute, why? Well, that's because when you add A squared and B squared, it's the same as adding B squared and A squared. The order in which you add doesn't matter. The order in which you name A and B does not matter. It is important, though, that C is by itself in this equation. So understanding that a right triangle, this will always happen. So that means if I give you three numbers, let's say we use 4, 5, and 6. And when we did the triangle inequality rule, we learned that if we added 4 and 5, it's bigger than 6. So these are the sides of a right triangle, or excuse me, of a triangle. We are now trying to figure out, is it a right triangle? So the question is different. And you have to be careful because that's where they get you on a test. Is this a right triangle? Well, how do I know? It must coincide with this formula. Well, Fraser, they haven't given me which one of these is A, which one is B, and which one's C. And yes, they have. C is always the biggest. If it's going to work, C has to be the biggest. Doesn't matter which one of these is A or B. No. Well, let's try the formula then. We would have 4 squared plus 5 squared, and it must equal 6 squared. If this doesn't work, then it's not a right triangle. So let's do it. 16 plus 25 is equal to 36. And hopefully you understand that is not true, because 16 plus 25 will be 41. 41 does not equal 36. So if I ask you, is this a right triangle? The answer would be a big fat no. And the reason is this work. So you have to show this work all the time. You can't just say no. I have to see the work and the answer no. So this is one of the skills that we talk about in geometry that you have to have, the ability to be able to write out your problem. And many of you do, and some of you don't. All right, now there's something called a Pythagorean triple. A Pythagorean triple are groups of numbers that we see the most often. In other words, when I recognize them visually, I know it's a right triangle. So one of those is 3, 4, 5. 3, 4, 5 will always be a right triangle. That means if you have the measure of 3 on one side, the measure of 4 on the other, and the measure of 5 on the side, it's going to be a right triangle. It's called a Pythagorean triple. Meaning, I have memorized that 9 plus 16 equals 25. I've memorized it. And when you have problems that you do over and over again, eventually you're going to go, okay, 3, 4, 5, I get it. Or they give you 3, 4, and the last one's 5. But you have to make sure that the 5 is which side of the triangle? Correct, the hypotenuse. So understanding what the hypotenuse is and how to find the hypotenuse and then how to use the Pythagorean theorem is all really important. All right, so let's try and find the length of a side. Let's say they give us 2 sides. Okay, so we have 2 legs. They're going to give us a triangle, and they give us 2 legs. One is 20, one is 21. I want you to write out the problem and go through the process of finding the right hypotenuse. Okay? I will pause for about 5 seconds as you write out the problem, and then I will start doing the problem myself. Hopefully you can then check to see if you're following my steps. Hopefully so far so good. Now comes the tricky part. Who knows what the opposite of squaring is? Well, we've done some other algebraic opposites. The opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring, hopefully you know, is square rooting. They are opposites. So I go ahead and square root both sides. This is when I use my calculator. And if you follow along, you'll see how to use it. Second function, square root of 841 equals, and the answer is 29. So Notice 29 is equal to c, because I have to square root the number nc squared. So that means the hypotenuse must be 29. All right? Now you're going to go ahead and do 2 problems after I'm done with 8-1. Now this is the first pass of 8-1. We're going to do another problem where we find the leg. So now I'm going to be given 2 sides, and I need to find the leg, one of the legs. So here's my picture. And I would tell you to get in the habit of drawing out the picture. And I would draw it in the same direction every time, making sure that my hypotenuse is the side across. Right. So again, more math. What do you get? All right, and hopefully you wrote out the problem knowing that the hypotenuse is my c, so it would be 20 squared over here. And this one is 8 squared plus x squared. What makes this different is we're looking for the leg now. So I go ahead and do all my numbers, which is 64 plus x squared equals 400. I have to minus 64. So I get x squared equals 336. And then I have to square root that answer. And this is where this calculator comes in. The square root of 336 is 4 square root of 21. This is called simple radical form. You cannot write it as a decimal. It won't let you. In other words, on your calculator, if you don't use a for function, you can't get or if you don't use this scientific calculator, you will get a decimal answer. And it will be very hard for you to find the right answer because all of them are going to be in simple radical form. Very seldom do they change it to a decimal. Now, let's say you did the problem and you needed a decimal. Then that's what this magic key does here. It changes it to a decimal. And it changes it back again. So it's important to use this calculator because it does some of the mathematics that you are supposed to remember how to do for you. Okay? Simplifying radicals involves you finding the biggest perfect square that goes into the problem. I think it's much easier just to have the calculator. All right? And you'll be doing practice using this calculator to see if you can use it correctly, because the more you practice using it, the less likely you are to make what we call a fat finger mistake. That's just because you're going in a hurry and you double push a button, you push 2 buttons at once, you hit the wrong sign, you hit the wrong function. It's important to practice using this tool. All right, and then the last part would be finding a distance. Now, finding a distance is no different than answering the problem. It's just changing this to a decimal and then being able to round. Okay? So if I took that answer and I said, I need an answer to the nearest hundredth, then my answer would then become x equals 18.33. If they said to the nearest tenth, it would then be 18.3. This is where you have to understand rounding and have rounding skills. All right, so now what I would like you to do is on page 517 of your book, you're going to do just the lesson check. Problems 1, problems 2, and problem 3. And you'll have those problems ready for class, and I will check them, and they will be considered part of your notes and getting credit. All right. Thank you very much. Have a good night.